Good day to all my Form 5 students. Today we are here to continue on the chapter Redox Equilibrium, where we will discuss part 18. In this part, teacher will continue to discuss regarding factors affecting electrolysis of aqueous solution, and I will concentrate on the second factor, which is concentration of solution, especially anions in the solution. Now, before we start on the discussion, let me recap on what have we done in part 18 of our video. Now, in part 17 of our video. Now, in part 17, teacher explained regarding conversion of electrochemical series and how to read electrochemical series to standard electrode potential value. So, this means I won't be discussing regarding electrochemical series anymore. I will be concentrating on standard electrode potential. Now, value, standard electrode potential value, and here again, what's the most important rule that students must know in order to select anions and cations which are going to be discharged are, first rule, at anode, anions with a more negative E0 value or less positive E0 value will be chosen to be discharged. Discharged here in the sense of anode always donates electron. So anode, whomever can donate electron with a higher E0 value, higher negative E0 value or less positive E0 value, that particular ion will be chosen. And at cathode, cations especially, more positive E0 value or combination of less negative E0 value will be chosen to be discharged. Now, without further ado, let's look at two examples where students can see how concentration of aqueous solution will affect the product at anode, especially will affect the product at anode depending on the concentration and sometimes the standard electrode potential difference. Okay, so let's start. Look at the setup of apparatus. Of course, this is using carbon electrode. Okay, carbon electrode. Now, carbon electrode are inert electrode, different from voltaic cell, where voltaic cell students will be using two metals, okay, as the electrodes. Now, carbon electrode is inert electrode. Now, since carbon electrode is an inert electrode, of course, electrolyte will be taking part in the electrolysis process. Now, let's start on what happens. Sodium chloride, please note the molarity or the concentration of the solution, 0.001 mole per dm³. This shows that this is in a form of, technically, this is dilute solution. Okay, so dilute solution. So dilute solution has lesser than 1 mole dm³ molarity. So students must remember that any aqueous solution with lesser than 1 mole per dm³ molarity or concentration is considered dilute. Now, let's look at what are contained in sodium chloride solution. Sodium chloride solution has sodium ion, chloride ion, hydroxide ion and hydrogen ion. Now, since this is a typical dilute solution, we will look at the first factor to decide the anions and cations which are going to be discharged. Meaning, in order to select the anions and cations which are to be discharged, students must look at the first factor that I taught in part 17 of our lesson video, which is position in standard electrode potential. Now, meaning in anode, we have chloride ion and hydroxide ion. But at anode, look at the rule. We must choose someone who has the more negative E0 or standard electrode potential value, which is amongst hydroxide and chloride. Hydroxide and chloride, who has less positive or more negative E0 value. Now, can we see that this hydroxide has a lesser positive E0 value? So that is the reason why we choose hydroxide. Okay, let's do this. Hydroxide ion will donate 4 electrons to become water and oxygen. So students can find colorless gas bubbles. Now let's look at cathode. Cathode, we have cation hydrogen ion and chloride ion. Sorry, not hydrogen. We have hydrogen ion and sodium ion. Okay, we have hydrogen ion and sodium ion. Now, automatically, I know students are not very familiar for time being. So, automatically look at the rule that I have written for all of you, which is for cations, which is a cathode, please choose someone or some substance which has more positive E0 value or less negative E0 value. Now, please compare sodium and hydrogen. Between sodium and hydrogen, who has more positive E0 value? Obviously, hydrogen. Can you see this is negative 2.71 versus 0.00. This shows that hydrogen, the discharge of hydrogen is towards positive value already. So that is the reason why we choose hydrogen to be discharged, which is 2 hydrogen ion will receive 2 electron to become hydrogen gas. And the observation that students can see will be colorless gas bubbles. Okay, where both the gas from anode and cathode respectively can be tested. For to test oxygen, use glowing wooden splinter, and to test hydrogen, students can use burning wooden splinter where you get pop sound. So that is the basic, okay, test to test the presence of oxygen and hydrogen respectively. Now let's go to second example where students can look at the difference in the concentration. Okay, 0.001 mole dm cube versus 1 mole dm cube solution. Same solution but different molarity. Now, please remember that molarity for halide solution. Halide means any solution that contains halogen ions. Sodium bromide, sodium chloride, hydrochloric acid, hydrogen bromide. Okay, so these are all containing halogens. So halogens 1.0 mole, okay, 1.0 mole per dm cube considered concentrated. Okay, so this is concentrated solution. Okay, concentrated solution. Now, let's discuss on what will happen at anode and cathode. Now, one thing teacher would like to highlight here is look at the factor. concentration of solution and N ions. Now, why teacher have purposely wrote the word N ions is because I want students to remember that only at anode, teacher repeat, only at anode, the concentration of N ions are taken into consideration to be discharged. Teacher repeat, only at anode, the concentration of N ions is taken into consideration to be discharged, but not at cathode. At cathode, we'll follow the usual rule for discharging. Okay, now let's go to what happens at anode. At anode, we have chloride ion and hydroxide ion. Now, if we look at this rule, we are supposed to choose hydroxide ion. Anyone with more positive, less positive value, anyone with less positive value is supposed to be chosen. But thanks to concentration of chloride ion being higher than concentration of hydroxide ion, you will be surprised to find that chloride ion chosen more concentrated. So chloride ion will be chosen regardless or ignoring this rule. Okay, but please remember, teacher repeat, only at anode. Right? Okay, now what happens is 2 chloride ion will donate 2 electron to become chlorine gas. Okay, and the color for chlorine gas is yellowish and a tinge of greenish, greenish gas bubbles. And for further confirmation, students can test this gas collected using blue litmus paper. You will find that the damp blue litmus paper, where you can find the damp litmus paper changes from blue to red and bleached. That means become colorless. Why? Because chlorine has bleaching property. Alright. Okay, now let's go to discussion on what happens at cathode. At cathode, as usual, we know sodium ion, cation, and hydrogen cation will be collecting themselves in here. But regardless, the concentration, that means the concentration rule only applies to anode. At cathode, you will be wondering if chloride ion is higher, chloride ion chosen. Definitely, sodium ion is higher, teacher. So, I think sodium ion will be chosen. But please remember, this concentration factor only plays a part in anode, but not in cathode. That means, regardless the concentration, how much the concentration is, always for cathode, students have to follow this rule. Meaning, amongst sodium and hydrogen ion, choose the substance which has lesser negative value. Either one, you can choose either one, more positive E naught or less negative E naught. So between negative 2.71 to 0.00, we have hydrogen with lesser negative because towards the positive already. So obviously you will be choosing hydrogen ion to be discharged. Okay, and that is the reason why you can see colorless gas bubbles produced. Okay, colorless gas bubbles produced. Okay, so I hope students can understand what teacher have mentioned in the second factor, which is concentration of solution, especially N ion. Okay, so if the concentration of N ions affect the product at anode, please remember that So that is the reason why teacher wrote anions. At cations, no, nothing will happen. Okay, cations will basically follow this rule. Alright, so I hope students can understand what teachers have mentioned in this video. Please watch this video few times in order for students to can understand, okay, the concepts explained in this video. Okay, so I will see all of you in more video, and also third factor affecting the product of electrolysis in aqueous solution. So till then, see you all, take care.